Hey everyone. If you're watching this, hopefully you are opened in the first part of the proportionality part, where we're going to talk about proportionality in tables and how we can tell if they're proportional or not, and how to write equations and find the constant and all of that. But before we do that, I want to just warm us up a little bit with equations. Equations is something we need to continue to talk about over and over again. So solving this equation, the first thing we're going to do is the distributive property. Some of you, where you have a hard time, is when you are multiplying a fraction by a whole number, a fraction by a fraction. So I'm just going to take this off to the side. And before I do that, remember the distributive property lets us multiply over parentheses for a sum or a difference. So I want to do 2/3 times 12. It's really 2/3 times 12x, but I'm going to drop the x for right now, just to show you it's just everything that you know about fractions. So 3 goes into 3 once, it goes into 12 4 times, so now I have 2 times 4, which is 8, but then we need to bring the x down. So now I'm going to do 2/3 of 9. So 2/3 times 9, I'm going to drop a 1 under there. 3 goes into 3 once, it goes into 9 3 times, so 2 times 3 is 6. And then I'm going to finish the equals 30. And from here, it's just straight solving equations. I'm going to draw in my line. It says, here's my variable. That's what I want on the side by itself. It says plus 6, so I'm going to subtract 6. So now I have 8x equals 24. It's multiplied by 8, so I'm going to divide by 8. So x is 3. And then, of course, you should plug it back in to make sure that it works. I'm not going to take the time to do that now because we have so much to talk about as far as proportionality. Alright, so the new part of the unit, we're going to be looking at proportionality, and specifically today about proportionality on a table, how we can tell if a relationship is proportional from a table. But to do that, it will be helpful if you remember how, just looking at ratios, if you can tell if it's proportional. And there are 3 different ways to do that. The first way is to check the unit rates. If the unit rates are the same, then you know it is a proportion. So 3/6 can be reduced to 1/2, or 0.5 for every 1. And 9/18 can be reduced to 1/2, or 0.5 over 1. So we know that the unit rates are the same. The second way we can check is a common factor, or a common multiple, I should say. So here we can multiply the numerator by 3 and the denominator by 3, and it makes a true statement. So we know that it is a proportion because of that. And the last way, and I use this a lot with problem solving, is cross multiplication. Cross multiply. We know that if you multiply, these are called the extremes, 3 times 18 and 9 times 6, they should come out with the same thing. So 9 times 6 is 54, and 3 times 18 is 54. So all 3 ways check out. You really only have to check one way, but make sure you understand that there are 3 different ways to check for proportionality. So common terminology, or common vocabulary that I see a lot on standardized tests, is the idea of directly proportional, or asking if the variables vary directly. That just means as one increases, the other increases at the same rate. So for example, these 2 pictures of Mona Lisa. This one has the length of 3 units, and the larger one has the length of 6 units. So what is that common factor? What did we have to do to 3 to get to 6? Well, we multiplied by 2. So if we have it in proportion, that means the width has to multiply by 2 as well. So our x is 4 units. When the length doubled, the width doubled. So because it was doubling, the scale factor, and we're going to be talking much more about this when we get to geometry, the scale factor is 2. That is our common factor. And how do we know? Well, if you set it up as a proportion, 3 is to 6, as 2 is to what? You can cross multiply to solve, or you can say 2 is to 3 as what is to 6. So we had to multiply the 3 by 2 and the 2 by 2 to get to 4. So many different ways. We are going to be talking specifically about scale factor again once we get into geometry, but proportional relationships, whether it is in art or math, they have the same principles. So there are many different ways to think about when relationships are directly proportional. Directly proportional, again, the definition, as one variable changes, the other variable changes in proportion to the first. For example, with this example, as the hours triple, so 1 times 3 is 3, the amount triples. 10 times 3 is 30. So they vary in proportion to one another. So if it doubled, so if we were at 1 and it doubled to 2, the amount doubles as well. We also know that a relationship between two variables is proportional if one variable is a constant. In other words, it goes back to that scale factor that we were talking about. If one is a constant multiple of another, so 1 to 10, 2 to 20, 3 to 30, what is that common multiple? The common multiple is 10. We can also find that by finding the unit rate, like we have been doing in the last unit. So 10 is to 1, as 20 is to 2, as 30 is to 3. They all simplify to 10 is to 1. Biggest mistake that I have seen is not using labels. So notice it is the y change over the x change. You're going to hear me say that a lot. It's the y change over the x change. We want to know how the dependent variable changes compared to the independent variable. The dependent compared to the independent. So this is our y, this is our x. This means the amount, so this is going to be our money compared to hours. So our constant multiple is 10. The unit rate is $10 per hour. So challenge, write a rule for finding the amount of any x. So again, let's look at that pattern. I'm going to erase this for a minute. What did we have to do? We multiplied 1 by 10, 2 by 10, 3 by 10. So if we had x hours, we would still multiply it by 10 to get 10x. So the amount is 10 times the number of hours, or we could just use y and x. Y is 10 times x. All right, let's look at a different situation. A bicyclist is riding at a constant rate. So that means the speed at which they're going doesn't change. 15 miles per hour. So we need to make a table for the first 4 hours of the journey. So we know at 0, he went 0. But at 1, he went 15. After another hour, he went another 15, which is 30. After the third hour, he went another 15, which is 45, etc., etc. So does this show a proportional relationship? So again, think of what we know about proportional relationships. Here are the ways we can check. As time doubles or triples or quadruples, whatever, if it is changing at a certain factor, does the independent variable change? So as time doubled, right here, if time doubled, did the distance double? Yes. 2 to 4, 30 to 60. What about if it quadrupled? 1 times 4 is 4, 15 times 4 is 60. So yes, no matter what, whether it is doubling or tripling, as x changes, y changes. So that is one way to justify. Second way, is there a constant multiple between variables? So going this way, besides our 0, 0, which I'm going to talk about in a little bit, 1 times 15 is 15, 2 times 15 is 30, 3 times 15 is 45, 4 times 15 is 60. In other words, there is that common unit rate, which we're going to see right here. So is there a constant multiple? Yes, it is 15. So the last way are all the unit rates the same. So we can put them in unit rate form. So remember, I want to see the, there we go, oh no. So 0, 15, I erased too much, 30, 45, 60. I want to see the unit rates. Are they all the same? 15 miles per 1 hour. 30 to 20 is also 15 miles to 1 hour. 45, I'm going to take it down here, 45 miles to 1 hour is also 15 to 1, sorry, 15 to 3. And 60 to 4 is also 15 miles per hour. So yes, all of the rates are the same. All the unit rates are the same. So here are 3 different ways that we could check. All 3 work out. So challenge. If we follow this pattern and we want to know what is the distance for x, let's say we don't know. Well, we know in every case we have to multiply that time by 15. So we can multiply that x by 15 to get the distance is 15. That's our rate times x. So notice in both situations, this coefficient of the independent variable, the coefficient of the variable is the rate. That's going to be important. All right, let's do a couple more problems. Here this shows the shipping price for different number of tennis rackets. So here we see the number of tennis rackets and here we see the cost in dollars. Is it proportional? So again, one way is x changes, does the y change at the same rate? So if x triples, y triples, if x doubles, does y double, if x quadruples, does y quadruple, etc., etc. So I'm just going to do triple this time. So 1 times 3, 2 times 3. So it does. When the number of tennis rackets triples, the cost triples. When the number of tennis rackets doubles, 2 times 2 is 4, the cost doubles. So yes, as x triples, the y triples. So yes. And as you're writing your justification, that's what you could put. Another way to justify, is there a constant multiple? If so, what is it? So what would we have to multiply x by to get to y? So 1 times 2, 2 times 2, 3 times 2, 4 times 2, x times 2. So yes, and it is 2. So we'll get back to this one in just a second, the challenge. And the last way to prove proportionality are all the unit rates the same. So I'm going to put them in a unit rate form. Remember, unit rate is just something over 1. So 2 is to 1. 4 is to 2 is the same thing as 2 is to 1. 6 is to 3 is the same thing as 2 is to 1. 8 is to 4 is the same thing as 2 is to 1. So all of the unit rates are the same. So yes, and the unit rate equals $2 for 1 tennis racket. And I want to emphasize again, when you're finding the unit rate, it is the y change over the x change, the dependent variable over the independent variable. Okay, so let's get back to our challenge. Write the rule. Write the rule. So in every situation, when we had a certain number of tennis rackets, we multiplied it by 2 to get the cost. So if there's x tennis rackets, we're going to multiply by 2 to get the cost. So the cost, and we could use y instead of c, but the cost is 2 times the number of tennis rackets. Or I could have written this y equals 2x. Again, where that rate that we found up here, is the coefficient of our independent variable. So let's take a minute to look back at what we know about proportional relationships. For all of them, for each of the ones that we were just talking about, when the independent variable was x, when the independent variable x was 0, what was the dependent variable? When the independent variable x was 0, what was the dependent? Well, if you look back, and you can page back and double check this, when we sold 0 tennis rackets, I'll write it down here, 0 tennis rackets, we spent $0. When we rode 0 hours, we went 0 miles. So for all of them, when the independent variable was 0, the dependent variable was also 0. This is called a zero, it's a very creative name, 0-0 relationship. And all it means, relationship, all it means is that all proportional relationships, if x is 0, then y is 0. Even if it doesn't show it on the table, because sometimes it doesn't. But this will be very important for when we're looking at graphs and equations. If x is 0, then y is 0 for all proportional relationships. All right, I'd like you to pause and do this next one on your own. See if you can figure out if it's proportional, decide how you're going to justify it, figure out the rate, and then write the rule or the equation. So pause for a few minutes until you finish that. Okay, so does this show a proportional relationship? Well, we have different ways of checking. We can look to see when the x is, let's say, tripled, is the y tripled. If it is multiplied by 6, is the dependent multiplied by 6. So here it's tripled, the y is tripled. It's multiplied by 6, 8 times 6 is 48. 1 times 8 is 8, 8 times 8 is 64. So it works. The other way you can justify it is unit rate. So here's my unit rate, and this is important. I'm probably going to show this way the most because this whole idea of y being on the top, the change in y over the change in x is really important. So y, 8 over 1. 24 over 3 is also 8 over 1. 48 over 6, 6 goes into 48, 8 times, so that is also 8 over 1, and 64 over 8. These all equal 8 over 1. And I want to make sure that you get in the habit right away of showing those labels. So what this 8 means, remember it's the change in y over x, so it means the amount earned, so dollars, over the hours. So it's y over x, y over x. So one justification could be that all unit rates are 8 over 1, or $8 over 1 hour, because we don't want to drop those labels. So what is the rate? It is $8 per hour. And the rule or the equation. So if we were trying to figure out how much money we learned in X hours, in every single case we were multiplying by 8. We were multiplying by 8. So the amount was 8 times n number of hours. If you would just want to do y equals 8x, that's fine. But again, this number, the coefficient of x, is our rate. All right, very last example before your assignment. Again, I want you to take a second to check all of the ways that we were working with proportional relationships. So is it proportional? Justify it. If it is proportional, then I'd like you to write the rate and the rule as well. If it is not, you can skip this. So let's see. The first one we talked about was that there was the x, let's just choose doubled, is when the x doubled, the y doubled. So 2 times 4 is 2. 2 times 2 is 4. 50 times 2 is not 150. So far I'm thinking no. But I'm just going to go through the other ways to check just to make sure you understand. We know that there has to be a constant factor. So 2 times 25 is 50. 3 times 25 is not 100. So there's a second way to check, and it's wrong again. And the last way is our common unit rates. So 50 is to 2 as 25 cookies for 1 hour. Okay, so that's the unit rate there. But here, I'm going to write this down here, 100 cookies for 3 hours does not come out to 25 over 1. So, no, and you could justify it. The easiest way probably to write the justification is the unit rates are not the same. And on your assignment, if it doesn't show a proportional relationship, we're not going to do the rate or the rule. That will be coming up in a future unit. So that's it for notes. So please open your assignment. Make sure you're paying attention to your checklist on what you should do, and we out.